Imagine trying to send a flawless 4K video feed along with perfectly synced stereo audio and like live keyboard and mouse commands to a screen that is literally sitting over a mile away from you.
Yeah, I mean, if you try that with standard copper cables, you'd get absolutely nothing, like total signal death.
Right, exactly.
Mm.
So, okay, let's unpack this because for today's deep dive, we're looking at a stack of your sources, specifically the technical specs for the Smart-AVI HFX-UX-PRO-TX-S transmitter. And our mission is basically to figure out how this thing solves those extreme audiovisual distance limits.
Yeah, and since traditional copper just can't handle extreme distances without, massive lag, the commercial AV industry relies heavily on fiber optics.
Okay.
But what's fascinating here is that traditional HDMI extenders usually require specialized dual fiber cables, like one dedicated to sending data and one just for receiving it.
Oh, so two separate physical cables.
Exactly. But this unit actually pulls off the exact same feat using an innovative single fiber cable connection.
Wait, if data is going in both directions through just one single thread of glass, why don't the light beams just crash right into each other and scramble the signal?
That is the exact engineering hurdle, yeah. It's solved by a physics concept called wavelength division multiplexing, or WDM.
Okay, WBM.
Right, so instead of just firing a white light down the tube, the transmitter uses entirely different colors, or wavelengths of light, to send and receive data at the exact same time.
Oh, I get it. It's almost like two people singing in a narrow canyon. Like if one is singing a high soprano note and the other is singing a deep bass.
Right, those completely different sound waves can travel through the exact same airspace at the same time without interrupting each other.
Makes total sense.
And then the receiver at the other end just acts like a prism, instantly untangling those different colors of light without any compression or, delay.
Which brings us to the payload itself, because combining these specific signals is notoriously tricky. I mean, we're talking uncompressed UHD 4K video at 60 hertz.
Yeah, alongside a completely separate, transparent USB 2.0 channel for your keyboard and mouse.
Right.
And if we connect this to the bigger picture, it's that specific combination that makes the engineering so impressive, because uncompressed 4K video is just a massive, constant waterfall of data.
Oh, for sure.
While mouse clicks, on the other hand, are tiny droplets, but they require absolute zero latency immediacy. So pushing that massive waterfall on those instant droplets simultaneously without a bottleneck is a huge feat.
Yeah, and here's where it gets really interesting, because the distance specs in these documents are just wild. It's pushing 10.2 gigabits per second of data.
That is a lot of data.
It is. And if you use single-mode fiber, it can maintain that payload over 2 kilometers. That is 1.24 miles.
Wow.
But if you use multi-mode fiber, it taps out around 1,000 feet. So why such a massive difference?
Well, it comes down to the core of the cable itself. Single-mode fiber has this microscopic, incredibly narrow core. Because it's so tight, the light travels in a direct, straight line.
Less bouncing around.
Exactly. Less bouncing means less signal degradation over long distances. Whereas multi-mode has a wider core, so the light bounces off the internal walls way more as it travels.
Right, which naturally limits how far the signal can go before it just gets messy.
Exactly. And this heavy-duty commercial-grade tech is doing all of this from a compact box that weighs under 2 pounds.
Wow, under 2 pounds.
Yeah, and it's built for environments that absolutely cannot tolerate a dropped frame or a lagging mouse click. Think places like a medical imaging facility where precision is literally everything.
Okay, so what does this all mean for you listening right now? I mean, even if you aren't personally wiring up a massive hospital wing, this still matters.
Definitely.
Because seeing extreme data bottlenecks solved like this really gives you a front row seat to the bleeding edge of connectivity.
For sure. It proves that the physical distance between where our heavy computing happens and where we actually interact with it is practically disappearing.
Right. Just think about your future remote work setups or, the future of edge computing.
Yeah, it changes everything.
Exactly. If we can already push a massive waterfall of 4K video and instantaneous control commands across a single thread of glass over a mile long, what happens to the design of our offices and physical spaces when the bulky hardware can be miles away and all you need in front of you is just a screen? Something to think about.